For our next problem, our first step says to solve one of the equations for either x or y. There's only one good choice here, and the one good choice would be the x in the second equation because it's the only one that doesn't have a coefficient in front of it. So that's the only one that's going to be easily solved in one step. To easily solve this, I'm just going to take the 2y and move it to the other side and change its sign. So I'm going to take the x equals that I've just solved for in step 1 and substitute it into the equation on the other equation. So yes, this is the one I just solved for, but I'm actually going to start with the 2x, but leave x open, parentheses, minus 4y equals negative 4. Then I'm going to take what x is equal to and plug it in to that spot, that empty spot where I erased the x. I'm substituting negative 2y plus 8 into the x spot. Now I only have one equation with one letter y, so now I can distribute and solve, which is step 3. Notice the new negative 4y and the negative 4y are on the same side, so when I add them I get negative 8y. A lot of students want to cancel those and then say, oh, there's no letters left, but when they're the same sign on the same side of the equation, you just need to add them. Negative 4y plus negative 4y is negative 8y. Just be a little bit careful there. Plus 16 equals negative 4. To solve for y, I'm going to subtract 16 to get all the numbers together on one side. And then I'm going to divide both sides by negative 8. So that's y is equal to negative 20 over negative 8. Now the negatives divide, and then 20 over 8, that can reduce by 4, so that gets you 5 over 2. So y is equal to 5 halves. And at this point, a lot of students are getting really quite scared because they're like, I don't want to have a fraction. But this one turns out not to be so bad. Remember, the next thing that we have to do, step 4, is to substitute your answer from step 3 into one of the original equations. I'm going to pick the equation that was solved for x, the one we did in purple, x equals negative 2y plus 8. And the y I know to be 5 over 2. Now you're thinking, oh no, there's fractions. Now you can use your calculator if you really want to, but the 2 in the numerator and the 2 in the denominator just undo each other, or cancel if you must. So that leaves me with negative 5 plus 8. And negative 5 plus 8 is 3. So this one didn't turn out to be not so bad. Again, you can use your calculator if you really want to. I'm going to go ahead and let you try that check on your own and move on to our next problem. Step 1, we need to solve one of the x's or the y's in one of the two equations. The only x or y that I would recommend is the second equation, x, because that's the only one that doesn't have any coefficient in front. So it's really easy to solve this for x by just moving the 3y to the other side. Whenever you pick up a term and move it to the other side, it changes signs. So that gets me x equals negative 3y minus 9. I'm going to take that and plug it into the other equation. The other equation says 2x plus 6y equals negative 18. But I left a big old fat parentheses for the x because I'm not going to use x. If I use x and y, there's two variables and I can't solve that. But if I take x out and replace it with what x is equal to in terms of y, which is the whole substitute step, then I have one equation with one letter. So when I distribute, I get negative 6y minus 18 plus 6y equals negative 18. On the same side, I have two y's. I have two terms of y, negative 6y plus 6y. Now, do you remember we talked about that on our last problem? When negative 6y plus 6y are opposite signs, these add to 0, and they do cancel out. Whereas on the last problem, we had negative 4y and negative 4y. Those were the same signs, so they didn't cancel out. They added up. Whereas on this problem, they are opposite signs, and so they do cancel out. So if they cancel out and I don't have any letters left, how am I going to solve this equation? Well, we did this earlier when we just did linear equations, if all of the variables drop out, then you have to ask yourself, is this remaining number statement true or not true? Well, negative 18 truly does equal negative 18. So the answer is infinitely many solutions, but we don't write just infinitely many. We actually write out what the solutions are. The set of all x, y such that, and then one of the two equations. I don't care which equation you like better. Either one is both correct, and this is my solution. The set of all x, y such that x plus 3y equals negative 9. That is a solution, meaning every single order pair that satisfies that equation. So there's not every number in the whole entire world, every ordered pair. It's only the ordered pairs that lie on this line will actually work. And our last problem, we have x to solve for x or y. The only one that's convenient is the x on the second equation. So then I get x equals negative 3y plus 12. I'm going to take what this is equal to and plug it into the other equation. The other equation says negative 3x, but instead of x I leave open parentheses, minus 9y equals 7. What can I say x is equal to? Well, x is equal to negative 3y plus 12. Now I only have one equation with one variable, y, and now I can solve it. Step 3 says to solve. So I distribute. Negative times a negative is a positive 9y. Negative times a positive is negative 36 minus 9y equals 7. Again, this is one of those special cases because on the same side, the y's, positive 9y and negative 9y, have the same value. And so because they have the same value and they're opposite signs, they add to 0. When I'm left is just numbers. So when you're left with just numbers, you can't have a unique solution. So this is going to either be true statement or a false statement. Well, in this case, this is not true. Negative 36 does not equal 7, and there's nothing you can do to make this true. So the answer to this problem is a no solution. And that's how that would look. If all of the variables dropped out, either you're going to get an infinitely many solutions or a no solution. So if I were to draw the infinitely many solutions, the two equations would happen to line up on each other, on top of each other. Now, I don't know what the equations actually look like, but if I were to draw it, they would actually be on top of each other. If I were to draw my last problem, just trying to relate this back to graphing, you'd probably have two parallel lines. And I don't know what direction they're pointing because I didn't bother to actually graph them. But no solutions are when they're parallel. So if I graphed it, they would have been parallel. And infinitely many solutions, the set of x, y such that, the equation, would be two lines that happen to be on top of each other. So that's how you would differentiate the two on that type of problem.